Hello everyone, welcome back all of you. In this session we are going to talk about measurement of pH, and to measure the pH we are going to study about one device called pH electrode, or it is also has another name as electrochemical cell. And before we go with that, we have to understand little uh, basic things about what exactly it means by pH of a solution. So pH is nothing but it is a short form of potential of hydrogen. So pH has full form as potential of hydrogen, and it is defined as number of H plus ions in 1 molar concentrated solution. So according to the definition, the number of H plus ions present in the 1 molar solution is going to be the pH of solution or potential of hydrogen. Or in the other case, it has another definition also, that is weight of hydrogen in 1 liter solution. So instead of talking about the number of H plus ion in 1 molar solution, we can talk in terms of grams of hydrogen in 1 liter of solution. So either way we can understand it, because sometimes it is might given in the form of gram per liter of the solution. So in that case we should be clear with the definition that the weight of hydrogen in 1 liter solution is going to be the pH of that particular solution. And apart from that, we have scales to measure the pH. So we can have two kind of scales. Either it can be H plus scale, or it can be a pH scale. So in the case of H plus scale, it is going to have range from 1 to 10 to the power minus 14, and in the case of pH scale, this can be written from 0 to 14, because pH is nothing but minus of log of H plus base 10. So if we have H plus as 1, so log 1 is going to be the 0 on any base. And if it is neutral, so we are going to have H plus concentration as 10 to the power minus 7, and if we put 10 to the power minus 7 over here, so base 10, so log of x power n base x, so it is nothing but n. So log of 10 to the power minus 7 and base is 10, so 10 to the power minus 7, so this is nothing but this minus 7 will come in front, so it will be minus of minus 7, so it will be plus 7, right? So if we have concentration as 10 to the power minus 14, so minus of log of 10 to the power minus 14 base 10, so it will be minus of minus 14, so pH will be 14. So either we can look it in terms of H plus scale, so 1 to minus 14, or in terms of pH scale, so it will vary from 0 to 14. And if the concentration is 10 to the power minus 7, or in terms of pH if it is 7, so we are going to call it as neutral solution. And if we have the nearest range on the left side, like near 10 to the power minus 7, we are going to call them as weak acid. And if it is nearer to the neutral but on the right hand side, so we are going to call it as weak base. And if it is on the left stream, we are going to call it as strong acid. And if it is very right stream, or it is very nearer to the pH 14, concentration 10 to the power minus 14, we are going to call it as strong base. So that is the basic idea about the H plus scale as well as pH scale. And also we have one dissociation constant, so that is nothing but H plus into OH minus is always is equal to 10 to the power minus 14, because sometimes it is quite possible that we are given with the concentration of OH minus. So and if we wish to know about the pH of that particular solution, first we have to get the idea about the H plus from that particular concentration of OH minus. And also I have taken the example of like OH minus is given as 10 to the power minus 12. So what is going to be the nature of solution, either acidic or neutral or basic. So what we have to do, first we have to make use of dissociation constant, that H plus into OH minus is going to be 10 to the power minus 14. So we have concentration of OH minus 10 to the power minus 14, so H plus is going to be the 10 to the power minus 2. So if we make use of formula, pH is equal to minus of log of H plus, so minus of log of 10 to the power minus 2. So we are going to get the value of pH as 2, and pH as 2 is going to be the somewhat nearer to this particular value, between 0 to 7, nearer to 0. So that is going to fall under strong acidic nature. So that's how you have to make use of dissociation constant. And now let us jump to our pH electrode or electrochemical cell. So the electrochemical cell, it is going to work on the principle of electrolysis. So let us have the quick look of the construction of electrochemical cell. That we have one tube, and inside which we have created vacuum, and we are going to have two electrodes, and one of the electrode is going to be in touch with the solution, because whenever you are going to place your electrochemical cell in the solution, so you are going to have one electrode in touch with the solution. So from there, if we have number of H plus ions, so we are going to have number of electrons as well. So the according to the ionization, we are going to have the electron as well. So electrons are going to travel through the hydrogen electrode, and also it has another name as measuring electrode, and the voltage of that particular electrode or the potential of that particular electrode we have taken as EM. And it is going to have another electrode, that is going to be the calomel electrode. What is calomel? It is the combination of Hg and HgCl. So the calomel electrode, and also it has another name as reference electrode. So the potential of that particular reference electrode, we are going to take it as E reference. So we are going to measure the difference of these two potentials, like EM minus E reference. So the measuring electrode we are going to take as positive, and the reference electrode we are going to consider it as negative potential. And we have to keep in our mind that the pH of the solution is not only going to depend on the concentration, also it has dependency on the temperature of that particular solution, or type of solution, or concentration of solution as well. Because if we are maintaining the solution at one particular concentration, but if we are varying the temperature, so we are going to feel the variations in the pH of that particular solution. So also keep in mind that pH is not only going to depend on the concentration of the solution, also it has effect of temperature or the type of solution. So in our case, we are first let us have the look of what is Nernst equation. So it is nothing but, as we are going to take the difference of measuring and reference electrode, so we are going to call it as nothing but magnitude of delta E as well. So EM minus E reference, and magnitude is going to be equal to minus RT by NF ln H plus divided by G plus, and G plus is nothing but concentration of gas, and we are going to take it as 10 to the power 0, so we will put it as 1. So we need not worry about the concentration of gas, so it is by default. We are going to remove it, and it will be having the dependency on the H plus only inside the ln. So and also in the Nernst equation we have constant R as universal gas constant, so it is having the constant value 8.314 joule per kilogram mole, and T is nothing but the temperature of the solution. So in our case, when we are going to encounter the problems, we are going to take the value of temperature as 25 degrees centigrade, or if we convert it in terms of Kelvin, we are going to get it as 298 Kelvin, because in the most of the analytical instrumentation applications, we are going to take the reference temperature as 25 degrees centigrade, whereas in the case of biomedical instrumentation, the reference is taken as 37 degrees centigrade, because the reference temperature in that case is taken due to the temperature of human body. So that is in terms of Kelvin, it is going to be 310 Kelvin, but we need not worry about the biomedical instrumentation reference. So in the analytical instrumentation reference, we are going to take the temperature as 25 degrees centigrade or 298 Kelvin, and N is nothing but valency of hydrogen, so it will be having the value as 1, because it was mentioned that it is going to depend on the type of solution as well, right? So in that case, valency of hydrogen is going to be the different, and F is nothing but Faraday's constant, that is 96,500 coulombs. So at 25 degrees centigrade, or in terms of Kelvin, it is going to be 298 Kelvin, because Kelvin is nothing but degree centigrade plus 273. So 25 means 25 plus 273 is 298 Kelvin. So if we put all the values of R, T, N and F, so we are going to get the simplified expression as delta E is equal to minus 8.314, T is nothing but 298, and divided by N is 1, and F is nothing but 96,500, and also this is ln H plus. So if we try to convert ln in the base 10, log base 10, so we are going to get the value as 2.303 and base 10, because ln is having base E. So this is nothing but log base 10 and H plus. Why in terms of log base 10? Because our pH is nothing but minus log of H plus. So we'll try to simplify this particular expression in terms of pH directly. So if we have the pH of solution, we can calculate the direct output voltage at 25 degrees centigrade. And if we solve this particular thing, we are going to get 59.13 into 10 to the power minus 3 and log base 10 H plus. So if we take this particular minus over here, so this will be minus log of H plus, and minus log of H plus is nothing but pH. So we are going to get delta E is equal to 59.13 and pH. And as there is 10 to the power minus 3, so the output we are going to get in terms of millivolts. So this is going to be our final output expression, the difference of hydrogen electrode and the reference electrode. So magnitude of delta E is going to be the 59.13 pH, and it is going to be in terms of millivolts. So if we are given with the pH, like if we have the solution pH as 1, so we are going to get the output voltage difference as 59.13 millivolts. So that's how you have to make use of Nernst equation at 25 degrees centigrade. And I am repeating it again, you have to be very careful that the temperature has to be given as 25 degrees centigrade, then only you can make use of this particular formula. So be careful about this, because the pH is going to depend on the temperature as well. So that is all for this particular session. If you have any doubt, you are free to ask in the comment section. Thank you.